Welcome to Space Messenger. Today, we have an incredibly exciting and groundbreaking discovery to share with you about the origins of life and one of Earth's most unique features, our oceans. Space enthusiasts will know it's easy to get caught up in a wealth of fascinating developments, from missions to the lunar surface to new discoveries in exoplanet science. But as an astronomer, what has me really excited right now is a largely overlooked development here on Earth that could have profound implications for our understanding of life's development on our planet. With little fanfare, the forthcoming Vera C. Rubin Observatory in Chile marked a major construction milestone on April 27th. Workers on the telescope finished a reflective coating on the primary mirror, giving it the power to capture light from extremely dim objects in the night sky that we currently cannot detect on a regular basis. This critical component will make the Rubin Observatory one of the most powerful telescopes on Earth, shedding light on a question that has perplexed scientists for decades. Where did our oceans come from? We know that Earth's oceans were a key ingredient for the development of life, but we are still not sure how they developed. Some of us think that our oceans were delivered by icy comets and asteroids from farther out in the solar system. Similarly, recently discovered interstellar objects like Oumuamua and 2I Borisov may tell us how oceans are delivered to planets around other stars. Certain chemical properties of Earth's oceans do not resemble what we would expect if the water was present when Earth formed. Astronomers believe that water must have been delivered after Earth formed, potentially from comets originating from the farthest reaches of the solar system, like the Kuiper Belt or Oort cloud. However, when the European Space Agency's Rosetta mission measured properties of water on Comet 67P Churyumov-Gerasimenko, these chemical signatures did not match those of our oceans. Part of the answer may come from learning more about one of the biggest new mysteries in the solar system: dark comets. Recently, we discovered 7 dark comets hiding among the asteroids close to Earth. These objects disguise themselves as asteroids, rocky bodies that do not have any water ice in them. However, we noticed that the dark comets were accelerating in strange ways. Comets are small bodies, like asteroids, that also contain ices such as water and carbon dioxide. When a comet heats up as it gets close to the Sun, this ice becomes a gas and gets blown off the surface, producing a rocket-like acceleration and a tail of gas and dust. These dark comets are accelerating like comets, but have no tails visible to our telescopes. If they contain water ice, they could have delivered Earth its oceans. If dark comets do contain water, they could be the missing link in our understanding of where our oceans came from. It is possible that these or similar dark comets in the past had water that resembles our oceans. Oumuamua was the first large body seen passing through the inner solar system that came from another star system, our first interstellar object. Like the dark comets, Oumuamua disguised itself as an asteroid because it had no obvious cometary tail, but it accelerated like a comet. We now think that Oumuamua and the dark comets contain ices that were invisible to us, and these unusual ices fuel their acceleration as they heat up and become gases. Astronomers have discovered rocky planets orbiting other stars that could harbor oceans and life. We now know that these exoplanetary systems have ejected enough interstellar objects like Oumuamua and Borisov into the galaxy that a tiny fraction of them must pass through our solar system. Just as dark comets could have given us our oceans, bodies like these interstellar objects could carry ingredients essential to the development of life on rocky planets around other stars, like our Earth. The fact that we have recently discovered both the first interstellar object and the first dark comets means that we are only at the tip of the iceberg. There are likely many more of these disguised comets, both from interstellar space and native to the solar system, lurking undetected in our planetary neighborhood. The Rubin Observatory is now one step closer to giving us access to orders of magnitude more observing sensitivity than we have today. We will soon be able to find what may be hundreds of interstellar objects in our solar system, as well as seeing accelerations in many new dark comets. Could dark comets and interstellar objects be the source of life on Earth-like planets? With the Rubin Observatory, we have the chance to understand these entirely new populations in the solar system and potentially where we came from. Don't forget to like, subscribe, and hit that notification bell so you never miss a cosmic event. Until next time, keep looking up.